hey geek friends. Alright, so let's get start. If you're ready, type in start. Like, yes, you're ready, type start. So we can start this game. Start the game. If you're ready, type start. Alright, so let's go. So this is the game that I'm going to play right now here. This will really help you understand how computers work in a really fun and easy way. So let's go. Oh yeah, hold up. Yes, please select your employee ID. Okay, I'm gonna select a new one. I have your photo here somewhere. Which one is yours? I'll pick this one. Yes, that photo looks just like you. Yep, exactly. Here's your badge. I just need a beard here, actually. Please proceed to the elevator. Okay, mailroom. Alright, so this is the first year. Welcome to your first day. You look like an excellent instruction follower. Your first job will appear over there on the right side in a moment. Remember, you can always ask me for help. Okay. Drag commands into this area to build a program. Your program should tell your worker to grab each thing from the inbox, here is the inbox, and drop it into the outbox. Okay? Cool. Now we just gotta grab inbox and outbox. Let's try. Run your program whenever you're ready. Here we go. But we got an error, of course. Not enough stuff in the outbox management. Expected a total of 3 items, not 1. So basically it told us that it expected in the output 3 items, but we only outputted 1. So how we can do that? Well, we're just going to do this 3 times. Inbox, outbox, 3 times. Oh, outbox, like this. Let's see. Boom. Here's the first one. Here's the second one. And here's the third one. Boom. Okay, so we completed the first year. Your presence is requested on the next floor. Continue to elevator. Okay. Busy mail room. Second year. Here we go. Well, looks like you've made it this far. Congratulations on your promotion. Most people stress out and quit before making it this far. And this is the story of every program. So, but I can tell you have a bright future in inbox outbox management. Here's your new assignment. Grab each thing from the inbox and drop each one into the outbox. You got a new command. You can drag jumps arrow to jump to different lines within your program. With this new ability, you can complete this assignment using only 3 total commands. Okay, now we have a new command called jump. Okay, and we have inbox outbox, and here we have a lot of boxes, right? So the last stage we just used a lot of inboxes and outboxes, right? But now we got a jump command. Okay, so let's see how we can do this. Inbox and outbox. But this will only get 1 box and it will input it, which is not enough. So how we can do it once again and once again and once again, like looping basically. So we gotta get the jump command and here. So see the magic happens here. Inbox, outbox, and it will jump again to the first line. Inbox, outbox, and it will jump again to the first line. So this is basically a loop when you hear a loop in programming or scripting, this is what it means. You're basically repeating tasks, okay? Inbox, outbox, then repeat. Yep, this is a loop. That's basically what a loop is, okay? And you can think of this guy as the CPU, as the processor, okay? This is the input. For example, the mouse. This is a mouse click. This is a left mouse click and stuff like that. And this is the output. For example, the screen pixels and colors. Okay. So you see how this game actually teach you how things goes. It's pretty cool. All right. So let's go. Continue to elevator. Loop. Yeah. So what do you think, guys, about this game until now? It starts with you like with two commands and then it scales from there. It shows you really how the computer works without telling you how the computer works. That's cool. And this will also help you in scripting, programming, and a lot of stuff. And to also actually understand how the computer works and how even programming and scripting languages how they work. Especially some concepts like loops, basically input, output, etc., etc. You'll see how it goes. So the copy floor. Let's go to the copy floor, and this will get so exhilarating. Oh no. I like that game. What's the name? Okay, I'll tell you the name. I'll type it in the chat. Human Resources Machine. It's on Steam. Okay, on Steam. Okay. So let's go. Oh no. The inbox conveyor system is completely broken. Yep, it looks like it's broken. So minus 99, minus 99. So it looks like it's broken. This is called an overflow. If you ever used programming using C++, for example, or C, you'll know that this is an overflow. But that doesn't mean we get to take a break from work. All right. So ignore the inbox for now. So we're just going to ignore the inbox because it's corrupted. And just send the following three letters to the outbox. BUG, or short for bug. The facilities management stuff has placed some items over there on the carpet for you. And here we go. There is 6 items, numbered from 0, 1, 2, 3, 4 to 5. And if only there were a way you could pick them up. Okay, so only if there were a way to pick them up. And I see that I have a new command called copy from. And with this carpet, here it begins the era where you understand the variables, like variables, and RAM, how RAM works, because this is essentially a RAM. And you'll see what it does in a sec. And that's just beautiful. By the way, what it's called a bug. What is a bug first? A bug is basically an error when something is wrong with your code, okay? But let me say something. Why it's called a bug? Is there anyone who knows why it's called a bug? And I'll tell you, so we don't waste time. Yeah, so we don't waste time. So when computers just started, okay, um, they were so big, and there were a lot of stuff going on, and they were open. They weren't closed, okay. And sometimes bugs, actually not even sometimes, but all the time, bugs go into the system or go into the machine, and they like basically they suck it up. They don't make it work, and that's why it's called a bug. Because in the past, uh, computers, the big computers, was not working because of bugs, of actual bugs. So yeah, let's go. Inbox. Not really inbox. We need the copy from. Okay, so we need to send to the outbox. We need to send bug. B-U-G. Yeah, I have a bug right now in a game I'm working on. I've never seen the error before. I have no clue what this means. Yeah, sure. I can help you with that. Actually, after we do something here, I can help you out. So bug, copy from. and we should give it the index 0, 1, 2, 3, 4, 5. So we'll go with 4 because this is where the B is stored. This is like a table, a lower table, or an array, and then you tell it copy from 4, the index 4. So we get the B, and we should outbox it. And now copy from U, which is 0, the index 0, and outbox it. Copy from G, which is the index 3, and outbox it. Okay? So I think you understand what's going on here. So let's see. B, outbox, U, outbox, G, outbox. Oh, cool. The error is waypoints. Not safe to call in parallel. I know Roblox is parallel now in Studio as a beta, but I have no idea what's fixing my script. It really depends. I need to see your script. You can show me, like, you can send me your script in Discord, and when we're free, we can look that up. All right. So continue to elevate it, and here we go. Now you just understood how RAM works in its basic level. Okay. Scrambler handler. The conveyor system is fixed, and just in time for you to get to work. The data won't collate itself, because basically what the computer does is just handle data. It's just like a master, a jogger of data. I don't know how it's called, but yeah. Grab the first two things from the inbox and drop them into the outbox in the reverse order. Now, at this stage, we're going from simple commands to really complex operations, okay? So right now, the game starts to actually show you how it can make crazy stuff, how it can do some crazy processes, some hard, crazy processes, okay? How you can make them using some simple commands, okay? All right. So let's do that. Basically, we need to grab the first two things from the inbox. We need to drop them into the outbox, just as we did in the first stage, but there is a catch. We need to send them to the outbox in the reverse order. And then we should repeat until the inbox is empty. And since when you hear in a task repeat, you should instantly know that you're going to use a loop, okay? A loop or recursion, but recursion is out of the scope of this game. But so in this case, a loop. And we have a command called jump, which we can use to make a loop. So let's go inbox. So we need to grab the first thing, and so we can reverse it. I need to copy it to, I need to store it basically. And I'm going to use the RAM here to store it. So I'm going to store anywhere, for example here, the index 0. And that's why it's called random access memory, because you can access anything inside of it in a random order. It doesn't matter, okay? Now, I'm going to get the first box. I'm going to put it in the RAM. I'm going to store it, and I'm going to get the second box, okay? Good. Now I got the second box. What I should do is I'm going to outbox it, because basically since this is in the reverse order, the second box should go first, okay? And the first box should wait. And now what I can do is copy from 0 so I can get the box that I stored before, and then I can outbox it again. Okay, and of course, since I need to repeat this for every 2 boxes, I need to use a jump. So I can do this again, over and over and again. So yeah, so let's see. 1, I store the first box, I get the second box, I output it, and I get the first box that I stored, I output it, and here we go. And I repeat the same thing again and again. And right now, I actually succeeded in sending the content of the inbox to boxes in the reverse order. So as you can see, by using simple commands, we did a crazier process. Okay, your presence is requested on the next floor. So what you didn't understand, Gojo? I can explain if you want. I can explain. Let me know what you didn't understand. Let me know, guys, if you don't understand anything, because I know this is a little bit hard. The game will get harder right now, so I can't explain to you anything you want. Okay, so let's go step by step. I can use this to get step by step. First, so basically what I want, what's the task here? Is that I have these boxes, and I need for every 2 boxes, I need to send them to the outbox, but in the reverse order, okay? And then I need to repeat this whole thing. Now I'm going to focus on the task. Okay, so first I grab the first box, okay? So here we go. I'll grab the first box. I grabbed it, okay? Now I'm going to copy it to, so I can store it. Basically, I'm going to store it here into the RAM. Now I stored the first box because it should go last, not the first. Now I'm going to go and grab the second box, and I got 8. Okay. Now I got the second box. What I should do with the second box, I should output it. Okay. And here we go. Now I'm going to get the first box that I stored, and I'm going to output it. Okay. I got the first box that I stored before, and I'm going to output it. Just like that. And now it was H1, and I've sent it like 1-8. Basically, the first box is the second, and the second box is the first. And now I'm just going to repeat this whole process for the other 2 boxes. Inbox, and I'll just go with that. I hope you understood right now what's going on. And from simple commands, we have done something complex. And that's how computers work. They contain some simple commands, and from those simple commands, we make even crazier stuff. Okay? So let me know if you understood this level. If not, we can repeat it, and we can explain anything you want, okay? Because if you understood how this game works, then you'll have a really good base for starting a program. I mean, if I had, yeah, so jump is just repeat. So if I had to start programming, okay? So basically, let's say I'm just starting to program. If I do know this game though, I'll try my best to master this game. Because this game really gives you the absolute essential concepts and skills you need. Yeah, kinda. So yeah, let's go. Continue to the elevator, and if you're done and you can understand all of these stages, we can go to the next ones. All right. So coffee time. This is basically a cutscene or animation. I need the coffee too, actually. This animation just tells you that programmers really love coffee. Oh yeah, power failure. The worst nightmare for a programmer. Now just imagine you're making a very big project and you need to deliver it like very fast, and then the power just goes on. I hope the power doesn't fail right now while I'm streaming because I will. I'll, damn it. I'll just hit my head with the wall because that happened a lot of like time where I was recording and the power just failed. Dude, that wasn't good at all. I just basically abandoned the whole video because like just imagine recording 1 hour and spending 1 hour of your time and then nothing, like it's all gone. But yeah, ugh, welcome to my personal rain cloud. How do you know how much Bobox did make a million viewers or a million views? It doesn't really depend on the views that much. Like it really depends on how much people click your ads and stuff. And for example, in this live, I disabled monetization because I don't wanna like kind of annoy you because the stream is already in a bad quality. So why do I need to enable goddamn monetization? I think right here in this light. So yeah, I was never very good at math since I have only 3 fingers on each hand. So he does only have 3 fingers, so we can only count to 3. While we have 10 fingers, so we can count to 10. But I hear you don't actually need to know very much about math to complete these assignments. Okay, I think that's understandable. Okay, rainy summer. For each two things in the inbox. Now, just when you have a task or you have a problem in programming, you should take it and you should break it down into parts, okay? So the first thing that we should see here, that we need to do something for each two things. You can count to 6 though. Oh yeah, that's right. Because you have two hands. So for each two things in the inbox, add them together. So this time we need to get two boxes. For every two boxes, we need to add them together and then outbox them. And here you're going to see how computers really shine. Basically, computers are made to just compute, just like get a number and then add it together and manage data. You got a new command, it adds the contents of a tile on the floor to whatever value you're currently holding. And as you can see, we have a new command called add, okay? And this is the same thing as an actual computer processor, as an actual CPU, okay? It does have these simple commands, and then you use assembly to use those commands to do all sorts of things, okay? For example, let's say you want to multiply numbers. You could just get a number and add it 10 times or whatever you want, and then you've got a multiply command and stuff like that. So yeah. Okay, now let's see. So we should get the first box or the first number, and we should sort. Okay, let's sort. You can sort wherever you want. So I'm going to sort here, and I'm going to get the second box. Okay, and the add command. Here's how it works. Okay, you got a new command. It adds the contents of a tile on the floor to whatever value you're currently holding. So basically, this command add takes the tile, or like the tile that you are holding, the box that you're holding, and it adds it to any tile in the floor that you. Oh, so okay, so add 0. Okay, now let's see how it goes. But well, I need to repeat the same task for all the two boxes, for each two boxes. So let's go. 3, I'll put it, and I'll get 6. I add them together, and then, oh, what? No, I forgot to outbox. I need to outbox the result. Okay, 0, 8, 8 plus 0 is 8, and then we output it. Boom. 4, put there, and 2 plus 4 is 6, and boom. Minus 1, I put it, I store it, and then I get the second number. 3 plus minus 1 is 2. Boom. Once you put it to copy to 1, then add. Yep, that's the same thing. You can do it here. You can sort in 1, you can sort in 2. It doesn't matter really. But yeah, you're right. So your presence is requested on the next one. So let's see step by step what's going on, if any one of you doesn't really understand what's going on, okay? So first, we get a box, okay? Now we got a box using the inbox command. Now we need to copy this box into somewhere in the RAM so we can store it, because we need to work on it, okay? Now, all right, I stored the first number. Now I need the second number, okay? So I don't need this number anymore because I already stored it, and I got the second number. And now I'm going to use the add command to add the number that I'm holding with the number that I stored before, which is the first number. And here we go, 8 plus 0. I added them together, and now I'm just going to outbox them. Boom. Now I'm going to basically jump, and I'm going to repeat the same thing all over again. This is how computers work. Like, essentially, this is how computers work. And this is really similar to the first processors. However, computers doesn't work with numbers like -7, 4, 3. No, it does only work with 0 and 1. But for the simplicity, this game works with the numbers that we use, not the computer numbers. So yeah, I hope you understood this level. Okay, so let's continue to the next level. These levels right here are a challenge. It's pretty hard to explain and to even do, but we'll look at them like later on. So Zero Exterminator, let's go. Year 7. And let me know your feedback. What do you think about this game in the comments? Like in the chat. So where do you see yourself in 5 years? Alright, that's a good question. So can you all guys like answer this question? Where do you, and if not in chat, just ask yourself, where do you see yourself in 5 years? To be honest, I don't know, but my goal is kind of to make I I don't really, but I think I want to make a game like a team that make games that are fun, but at the same time educational. For example, like this game basically. And I also want to make my own programming language just for the fun of it. And maybe a game dev company, I don't know. Like everything is I really want to be a software engineer, but I don't really go that way. Or maybe I'll go with physics, but it depends. So yeah. For 10 years. Okay, you can reply about these questions. I have a note here from your other boss that says, from this point on, your performance will be evaluated with extra scrutiny or scrutiny. What he's basically saying here is that he will actually he'll scores us basically like an exam kind of thing. What a treat! Okay, so basically, the more you use more efficient solutions, the best notes you'll get. So yeah. All right, now we got a new command, jump if zero. Oh yeah, here we go. We got conditions right now. Send all things that are not zero to the outbox. Wow, what a treat. Yeah. I live near the fuck. I forgot to wash. Send all things that are not zero box. Hmm. You got a new command. It jumps only if the value you are holding is zero. Otherwise, it continues to the next line. Okay. Um. All right. So inbox. First, we need to get the first, or to get the box, first box, right? I think. Yeah. Box, and we should see if it's zero. So if it's zero, what we should do. So if it's zero, I'm just going to get another box. If it's not zero, we're going to outbox. Okay, and when we finish, we need to repeat this whole thing. Let's see how this goes. 4, output, because it's not zero. 0, it's zero, so we get another box. Minus 2. D, it's not zero, so we unbox it. 0, we're just going to skip it. Minus 2, we're going to outbox. And 0, nope. And here we go. And I made it for the size challenge and the speed challenge. So yeah, I completed it using just 4 or fewer commands. So I used only 4 commands. And then I completed it in 23 steps. That's basically the speed. So yeah, we can go back and I can explain to you step by step. All right. So the first line is inbox. So let's see. Here's the inbox. We got a box, okay, which is 4. Now we're going to jump if 0. So if it's 0, we're going back. We're going back like we just started, and we're going to get another box. But since it's 4, we're just going directly. We're not going to jump. Okay, we're just going to directly to outbox. Yeah, it's kind of like an if-else command. Oh, yeah, so right now it's 4, so it's not 0, which means it won't jump. So we're just outbox. Boom. Now we're going to jump back and repeat the same thing. Okay? Inbox. We got an inbox. Here we go. 0. Now jump if 0. Since this is a 0, we're going to jump back, okay? And we're going to get another box, inbox, -2. Here we go. We got that. Now -2, it's not a 0, so we will outbox it. So basically, if we're holding a block that is 0, we're going to jump back into the start of the program. If it's not a 0, then we're just going to continue. We're going to outbox, and then we're going to repeat the same thing again. Okay? So, and this is the same thing that happens. And you can see this guy is like a processor, like the CPU, but just more faster. Okay? Let me see the speed. Okay, you can imagine this guy as your CPU, as your computer CPU, but just in the speed of light, okay? So here's the speed. Okay. You see how that goes? Boom! So the computer is really dumb and doesn't have much commands. It doesn't know much, you know? But he's just so fast, really fast, and so good at like executing orders. That's basically it. So if you're a good programmer, the computer is going to be your best help because it's like fast, so speedy, like the speed of light, dude. He does simple things, dude. How much gigahertz you do have? How much gigahertz you do have? So I can see if it's really that slow or not. Let me tell you how much fast my CPU is. Okay, so if I go to this, right here we go. And I go to the properties. Okay, please don't see my files because it's all junk. Okay, so this is my RAM. It does contain 8 GB of RAM. And here's my gigahertz. This is my CPU. It contains like, I think 8 cores, not sure. I guess just 6, really, 6 cores. Yeah, I think 6 cores. Okay, so it's 2.9 gigahertz. Alright, so how can I know how much instruction my computer CPU can execute a second? Okay, now let's see this. Let me get a browser right here. Here's what I'm going to do. I'm going to say gigahertz to hertz. Alright? And let's see. Let's see what's going on here. Okay. So how much? Let me see. 2.9 gigahertz. 2.9 gigahertz. Okay. Mine is 2.4 gigahertz. Well, does this just like crashed or something? Okay. Let me see. Okay, 2.9, right? Yep, 2.9. Let's try convert. Okay. So this is how much instructions my CPU can handle or can do in a second, in 1 second. Let me copy this to you so you can read it. Instruction per second. So you can see how much speedy or how much fast your CPU really is. And for 2.4 gigahertz, it's just like this. Convert. Alright, let me send you another message. CPU execute instruction per second. And what is an instruction, by the way? An instruction is just basically like you can have an instruction called add that basically add two numbers together, and an instruction called sub, which subtract. So yeah, let's go back to the game. See how fast that CPU is? Dude, that's just crazy. Zero preservation initiative. Now, I'll also tell you why the CPU is also like the RAM is also important. Okay. So, for example, it has come to our attention that the Zero Advocacy community felt the previous assignment was not inclusive. This time, send only the 0 to the outbox. What happens to the other numbers and letters? Management leaves that details up to you. Okay, so send only the zeros to the outbox. Okay, so it tells us to send only, because the last stage we sent all the numbers that aren't zero, but at this stage we should send all the numbers that are equal to zero. So how we can do that? Let's get our inbox, of course, and let's jump if zero. So this is all instructions, okay? So here I just did one instruction. Yeah, jump if zero. So if it's zero, no, I shouldn't go back into the inbox. I should actually outbox it up, okay? If it's zero. And if it's not zero, I should go back into the inbox, okay? And then let's jump and let's see this in action. So basically I'm going to repeat this whole task again. Let's see this in action. I'll explain everything into you. Just let me see how this goes. 3, 0, should outbox. -4, boom. I decide to just throw the other ones. Okay, -3 and 0. So it worked, right? And did you understand how this works? Okay, let me see. Alright, so let's go step by step. And let me explain this to you. Alright. Well, now the game is easy. Oh yeah. Okay, so inbox. Let's get a box. And then here we have a jump if zero instruction. So this is not zero, which means we're not going to jump, okay? And since we're not going to jump, we're just going to go to the next jump instruction. We're just going to jump into the start, okay? And then inbox. And now it's zero. Jump if zero. Jump if zero. And just like I can. So now, right now I'm going to jump through the jump. Okay? So I'm not going to go back into my program. I'm going to execute the outbox instruction. And I'm going to jump again. And boom. Let's get another box. So if it's zero, then we're going to jump. If not, we're just going to go through to the next command, jump. We're going to go back. For C, it's not zero, so we're going to jump again. And for zero, it's actually zero, which means we're going to jump. We're not going to go to the next level, or actually, we're not going to go back, okay? We're going to continue. We're going to jump on the jump. So yeah. Okay, so basically skip that jump. The game name is resource, I think, human resource. Yep, human resource machine. Okay. All right. So Outbox, and that's basically the case. Yeah, human resources machine. That's true, D friend. Oh yeah. All right. And that's basically how it works. And let's go back and let's speed it up. Okay? And here we go. Our CPU going fast. I'm fast, boy. All right. So we did it. Continue to the elevator. Sub hallway. Now, let's see. Subtraction. I never learned that in school. Did you? I guess I did. Damn costly, 14.99 USD. Yeah, it's 15 USD. Yeah, that's too costly, but it's really worth it. Whichever. We're a good team. For each two things in the inbox, first subtract the first from the second and put the result in the outbox. And then subtract the second from the first and put the result in the outbox. Repeat. Got a new command. subtracts the contents of a tile on the floor from whatever value you're currently holding. Alright, so we got a new command called sub, which of course will subtract. So for each two things in the inbox, as you can see, for each two things in the inbox. So let's get an inbox and let's store that in here. And let's get another box. Okay. Now we get the second number. Now we need to subtract the number that I'm holding from the number that is on the floor. Or actually the opposite. So subtract the contents of a tile on the floor. So I'm going to subtract this number that is on the floor from my number that I'm holding. Okay, and then I'm going to Outbox. And then I'm just going to repeat this task forever. As long as we have boxes. 2, boom. 5, 5 minus 2, 3, and Outbox. And we're going to jump. I'm going to repeat. 9, 1, 1 minus 9, 9 is 8, and boom. But what's going on here? Okay, so I think we didn't seen the whole thing, but yeah, let's see. That outbox measure expected minus 3, but your outbox is minus 8. Okay, so we got an error. Why? Let us read the question or the task again. For each two things in the inbox, first, so as you can see, there is two things. First, subtract the first from the 2ND, which is what we did, and put the result in the inbox. Okay? We did that, but now it says, yeah, and then subtract the second from the first, and put the result in the outbox, repeat. So basically, we didn't read the whole thing right now, and this is a good example. When you're programming, when you have a task and you have a problem or an error or something not right, you need to put or to read your instructions again. You need to read your task again. And this is the same as math, because sometimes we don't read the whole thing, and sometimes we just miss some important key information. So you should reread your task and try to figure out what you've done wrong. And in this example, I didn't read the whole thing, and there is two tasks that I need to do. I need to subtract, for example, 3 and 8. I need to say 3 minus 8 and also 8 minus 3. And since I need the two numbers to be stored, I need to store the 2. And here where I'm going to use my second memory spot, RAM. So this memory, it only have 3 slots, but your computer memory have like millions and even more. So yeah. Inbox, copy to 0, inbox sub 0, outbox. And your hard disk contains even more slots. But it's so slow because it's far. It's like I'm going to go out of this door, I'm going to go to the store and pick up something. That's going to be so slow. That's the same thing as storing information in your disk and storing information in your RAM. Storing information in your RAM is so fast because it's near you, okay? But storing information in your disk, it's like going out of the door and going into the store, store something, or load something, and then go back to your room, which is, as you can know, it's so slow to do so. Anyway, wait, we need to redo this whole thing, kind of. So instead of subbing directly, when we get the second number, we need to store it too. So let's sort that. Copy to 1. And now we sort the first and second number. Yeah, I really explain it so plain and simple because this game really makes it much easier to imagine what's going on and to see, like, for example, in school, when your teacher is explaining math, for example, is always talking abstractly, okay? He's always talking about numbers and stuff, but he doesn't really tell you about like how you can relate those numbers and those operations to the real world, and what's our goal, which is right here, and how we can what's our tools. The tools are here. Okay. All right. So let's go. Now we got the first number. We sort in the first index. We get the second number. We sort in the second index. Cool. Now what we should do, we're going to sub because now we're holding the second number. Okay? Now we can subtract the second number from the first number. But I think that would won't work because they want to first subtract the first multitude and the. But let's just make sure that's the case. This is Outbox for a sec, so we can see even what's going on. So 2, I'm storing it. 9, I'm storing it. And now I'm just going to do, okay, it worked. Okay. All right, I see. Now we can just go ahead. And I think you need to use copy. It looks like it works. I think the order doesn't matter here. So yeah. Now what we need, yeah, I need to use copy. Yeah. Copy from. Okay, so I've subtracted the first number from the second. Now I need to get the first number and subtract it from the second. So we're going to get the first number again. We're going to sub it from the second one. And we're going to outbox. Okay, and we're going to repeat, of course. Let's see how that goes. 1, the first number is stored. The second number is stored. Now we're going to do a sub operation. We're going to output. And we're going to do the opposite now. 1 minus 7 is minus 6. And now we're going to do the same thing once again. 9, 4, 4 minus 9, minus 5. Then we're going to get the other number. 9 minus 4, 5. And we're going like that. It just keeps going like that. But your CPU is so fast in the speed of light, basically. And you can execute operations like millions or even more. So yeah, that's pretty awesome to even think about. That even while I'm playing this game, there is a lot of instructions going on my CPU and a lot of things happening in that little box right there. So sub hallway, size challenge, and speed challenge. We made it. So that was the best solution, I think, at least for the game. So yeah. So now, let me know, do you want me to go and do the challenges right here? This is the challenges. Or complete the other ones, the other levels. So what do you think? Should we go to the next levels or complete the challenges? So are you ready for the challenge? Yes, challenge. All right, good. All right, let's go. So tripler room. So from now on, this will be a little hard, but I can explain to you and we'll go step by step to understand it, okay? All right, let's go. Tripler room or tripler room. Okay. Who are you? This optional area is for high-performing employees only. Oh yeah, we're legends. Is that you? Well, you're late. 7 years late. Because I left the challenges and I completed the other stuff. This is like your teacher. I need to make some changes around here. I want to see a 100% performance increase. From this point on, your performance will be evaluated with extra scrutiny. Alright, so let's get it step by step. Alright, for each thing in the inbox, triplet, and outbox the result. Self-improvement tip, where are we going with this? Please, leave the high-level decisions to management. Okay. So basically what we got here is that we need to get every number and multiply it by 3, okay? But we only have an add command and copy from, copy to inbox, outbox, jump, okay? So how we can do that? First of all, let's do it the normal way or actually, yeah, that's the only way anyways. So yeah, let's get a box, inbox. So we get a number. Not watching my What? Hey, what's up? Your name is so crazy. What? Welcome, dude. Welcome. Inbox. Okay. Now what I should do is actually copy to. Nice username. and we're going to copy it to 0. Okay, we're basically going to sort that number, and we're going to add it 2 times. Add and add again, so we can actually triple it. And outbox, we're going to repeat the same thing. Okay, now watch the magic happen. 5, put 5, and add it. Add it again, 15, outbox. Minus 4, boom. Minus 4 plus minus 4, minus 8, minus 12. Boom. 2, 2, add it again, and add it again, boom, 6. 0, it's 0. See what's happened there? That was pretty great. 6 and 24. We did it. Let's go back and let's go step by step. Okay, so first we get a number, inbox number. So I got 5. Yeah, that wasn't hard, but the next challenges will be even harder. And if you don't think systematically, even this level can be hard. For beginners, especially. So 5, okay? Copy to 0. Okay, now we store that number. Now we want to add that number to the same number, basically. So we're going to add. So 5 plus 5, 10. Now we just have successfully multiplied that number by 2. Okay, now we're going to add that number to the total again. So we triple it. Plus 5 and 15. Okay, now we just multiplied by 3. If we want to multiply by 4, we can just add another and so on. Okay, now we output it, and the same thing goes on. We can make it fast. All right. Okay. Continue to elevator. Good. You didn't understand that? Well, let's go back. I think you didn't understand it. What you didn't understand if you don't. Let's go step by step. Once again, replay this time. We're going to inbox. We're going to get a number. And we put it. We sort it. We add that number 2 times, 3 times, and we outbox. The same thing goes again. Minus 5. Grab that number. Put it down. We add 3 times, basically. Or 2 times because we already have 1. And boom. We do the same thing once again. 6. 6. 6 plus 6. 12. 12 plus 6. 18. And outbox it. 0. So basically what the processor does, it grabs the input, which is like a mouse click, for example, or anything like that. It grabs your inputs, it does some processing in the background, and it gives you the output that you want. Okay, and the instructions that execute it, it's the one that you give it. Okay, so that's basically it. The CPU is so like stupid, but it does things very fast, which makes it pretty good for calculation. Okay, continue, and also for automation. And now the next challenge. Just drop pixel blocks. This will be hard for you to follow along. Oh yeah, you gotta go. Alright, bye man. So Explorer suit. Now this will be much harder, but we can do it. Yes, you can always check your own performance on each assignment's optimization challenges. The 2 green lights next to each button in the elevator will tell you how I'm doing. Whichever. Is there anything in life more thrilling than self-improvement? Alright, yep. There is nothing. For each thing in the inbox, right? Multiply by 8. Okay. And put the result in the outbox using a bunch of add commands is easy, but wasteful. Can you do it using only 3 add commands? Management is watching. As you can see, this is much harder. But let's do it the wasteful way. Let's do it the normal way that anyone would do, okay? We're going to get inbox, and we're going to copy it to 0. It's not that hard. You'll see how it goes. But let's just do it, okay? So copy to 0. And the normal way of doing it is just to add 7 add commands. So let's do that. 1, 2, 3. I think I can copy. Oh, no. Let's copy or add. So 1, 2, 3, 4, 5, 6. And that should do the trick. And outbox it. Okay? And of course, repeat. So this will execute the task, but it's not good. It's not optimized, basically. So 5 times, oh, yeah, I need to add another one, actually. Yeah, but wasteful. 1, 2, 3, 4, 5, 6, 7. Do I need to add another one? I think so. So 8 commands. 1, 2, 3, 4, 5, 6, 7. Oh, yes, 7, yep. I don't even know how to count. 2 times 8 is, I think, 40. So, or 20, I think. Wait, what? 16. God damn. Minus 4. The same thing goes on. As you can see, it worked, but wasteful, not optimized. Now, what we're going to do, so as you can see, I didn't complete the challenge. Now, what we're going to do is something called optimization, okay? Is that we need to optimize this code. So how we can do that? Well, let's go back and let's do it from the start. Actually, let's clear everything. Let's do it from the start, okay? All right, now you need to focus a bit with me here. So we need to get the number, okay? And we're going to copy it to 0. All right, good. And we're going to add it again. Now we just multiplied by 2. All right? And let's multiply by 4. So here 2, 3, and 4. Now we multiply that by 4, okay? Now let's see what's happening here. 2, 2, 2 plus 2, 4, 6, 8. Okay? We got 8. Now we got 8, which is times 4. Now what we need to reach times 8? We just need to get that times 4 and multiply by 2. So how we can do that? Well, we can just start again. We can copy 2, 0, and then add it. Only 3 commands, by the way. Oh, what? But we'll see how it goes. Outbox and jump. Okay. 6. We need to multiply by 4 first. And then store that and multiply by 2. And here we go. So you see what happened there? So you know what? We can use just 3 add commands. How? You can ask me how. So let's redo this again. You see what's going on here? We're just getting the result and we're storing it again. And we're multiply again. So add. And this time let's copy to 0 again. Now we're going to store the 2, okay? So now we need to basically add it again. Add to 0. Let's see. So 6, we're going to put it. 6 plus 6, 12. 12 plus 12, 24. So right now we just got that. Copy 2. We're going to put the result and add it again. and then we're going to Outbox. So see what's happening here, because the one is pretty good to see what's going here. So basically every time we add, we store the result back, and we use that result to add again. So let's see. 1, 1 plus 1, 1 plus 1, 2, 2 plus 2, 4, and we store it. 4 plus 4, 8. Boom. And it goes on like that. So what do you think? We only used 3 add commands. So that's wasteful too. Like if we have jump if 0, for example, then we can see if it's 0. If it's 0, then we can just like send 0. We don't need to multiply it. We don't have that jump if command. So I completed the challenges, which is pretty good. And do you want me to repeat this? Do you want me to explain more? Or let's go step by step, okay? And we're lucky that we have just one here. Game is helping us actually. Okay. So let's get a number. So we need to multiply by 8. That's our goal. We're going to store that number. We're going to add it. So right now, we got 1 times 2, okay? So that number multiplied by 2. And we're going to get that result, and we're going to store it again, okay? And now we're going to add those results together again. So now we have times 4, okay? And we're going to store that result again. We're going to get, now we have times 8, because we took times 4 times 2, which is times 8. So that makes sense. And now we just completed the times 8 multiplication. And same thing goes again. Let me redo it once again. Minus 3. And we add it together. We store the result. Add the result together. We store it. We add it together. And we do that. So we can use this strategy to multiply by numbers like 2, 4, 8, 16, 32, like what's else? 64, 128, 256, 512, and 1000. And it goes like that. So yeah. So any multiplier of 2, basically, where I have like multiplied by 2 every time. But yeah. Now let's just speed up this and let's go to the next stage, which of course will be much harder, but we can do it. Continue. Now, as you can see, I completed 2 challenges. So tetra multiplier. Tetra. What a wonderful feeling when all your work over the last few years all comes together. So this is basically the same that I said about like when I got the money to actually buy a new computer using scripting. That was really awesome. Now I got like the computer that I'm using right now is a gaming computer that I worked hard for it for years for learning, and now I'm good. And culminates in a well executed assembly. Now I only need a better network, and we can stream every day, so, and even with a better quality. And it can teach you a lot of things. I can help you, and yeah, culminates in a well executed assignment. Okay, and now here is the great challenge. For each thing in the inbox, multiply it by 40 and put the result in the outbox. Now this is a little hard. Why? We can't use the same strategy that we used before, because that strategy will only work for some numbers. And I'll show you those numbers. I need to type them up so you can understand more what I'm talking about. Okay? So I can use that strategy only for numbers like 2, 4, wait, what? 2, 4, 8, 16, 32, and 64. So I can only use that strategy for this case, alright? So I can't use that strategy because we need 40. And here it doesn't go from 32 to 40, but 64. So you can't really use that strategy. So we can stop at 32. I'll show you how you can do this, okay? So here's the case. Let's say I have a number, for example, 1, okay? What I'm going to do that number to reach 40. I'm going to say times 2, which will give me 2, okay? And 1. How long have you been scripting? Your videos are so much better and explain better than other books who was scripting on YouTube. Around, you can say between 4 years and 5 years, okay? Now, what we're going to say is going to grab this result, which is 2, and we're going to do times, or actually, yeah, times 2 again, which will give us 4. Sorry, that was, yeah, you're welcome. You can ask me any question anytime. You're really welcome, okay? Okay, so 4, we're going to get the results from this last operation, which is 4. We're going to do times 2 again, which will gives us 8. Now, we gotta think about how we can get times 10, okay? So let's think about it. We got the results for times, we got the results of 8. Can't we add 8 and 2? Can't we add the first result that we got, and which is just times 2, and the the third result, which is times 8, basically? So basically, if you have a number like 1, you can do times 2 plus 1 times 4, right? Which is 2 plus, actually 8, right? Yeah, 8. Or we can say times 2 times 2 times 2, because we did this operation 3 times. Okay, so here plus 1 times 2 is 4, and 4 times 2 is 4 times 2 is 8, right? Wait, 2, 4, and 8. So 2 plus 8, and it's equal to 10. So we got a 10. So this is the solution. All right, let's execute this solution. So let's grab a number inbox, and what we're going to do is we're going to copy 2. We're going to store it in the RAM. Okay. Now what we're going to do is add. So we're going to multiply that number by 2 by adding to it, and now we need to copy from that, I think. Yes. Copy from that and add it again. So now we got times 4. And let's do the same thing again to get times 8. Wait, add 0. And let's just see if this, or actually just go in. So we're going to get a number. We're going to store it. We're going to add to it 0, which means we're going to multiply it by 2. And we're going to get the result. So times 2 times 4. And here times 4 times 8. Now we got the 8. But remember, we need to store the first result, which is times 2, okay? So let's make sure to store it, because we're going to need it, okay? And now what we can do is we can add the result to the other result, and I think that should work. And that should give us, oh, this will only give us, by the way, this will only give us 10 times 10. Now how we can do that to multiply it by 40, but actually let's see first, let's see if this will work with 10. So 7 plus 7, 14. I'm going to store times 2, and I'm going to do times 8 plus 28. I think that's wrong, right? because we start with 7, I think. 28. What's happened exactly? Let's go step by step. Oh, a 1 is pretty good to use. 1, 1 plus 1, 2. And we stored the 2. Oh, why copy it from? Oh, what? Wait, what? What's happened there? 1, 1, 1 plus 1. I put it there. And I shouldn't copy from. Yes. Yeah. Yep. And I don't think I need this. So let's go. I hope it gives us like a 1 because it's much easier to deal with. Okay. 1, we put a 1. 1 plus 1 is 2. Now we multiply that number by 2 and we'll store the result in another place because we'll need it later on. So 2 plus 1 is 3. What? Okay, wait. Copy to 1, add 0. Oh, I need to copy it to 0 too. Copy 2, 1, 1 plus 1, 2. We store that. And we put that number, that result. Now we add them together. What? Copy from. No, I should use add here. Wait. Here we go, we added it. Copy from. What's copy from? No, copy to. What the heck? Huh. Okay. So this should give us something. Let me work with 1. Yeah, here we go. Alright, 1. 1 plus 1, 2. So we store the result of the multiplication by 2. 2 plus 2, 4. 4 plus 4 is 8. Now we got the multiplication of 8. Now we can add that result that we got from the multiplication of 8 with the result of the multiplication by 2. So we're going to get 10, okay? And it's easier that way because we have 40. Because we can actually multiply by 4. So that would work. Okay, so let's add the result that we stored before, which is the multiplication, or the result of multiplication by 2, which will give us 10. Let me just show you that. I'll look for 1. Here we go. Now, let's go. Let's see how that goes. 1, 1 plus 1, 2. We store the result, and boom, boom. We got 8. Now we're going to 8 plus 2. Now we got 10. Now it's easier because we can say 10 times 4. We can just grab the result that we got now, and we should multiply by 4, and we got the result by 40. That's so cool. Okay. Now where to go from here? I think we need to copy to 0. Okay. And then I need to do the same thing to multiply by 4. Add 0. And then I'm going to copy to 0 and add it again. And that might be the solution. Let me see. Let me get a 1 again. So I can see if this will work. Damn, come on. Give me a 1. Please. Here we go. So let's see how that goes. 1. 1 plus 1. 2. 2 plus 2. I just want to know if this is right or not. 8 plus 2, 10. 10 plus 10, 20. 20 plus 20, 40. Here we go. Now we can outbox it because that's the result and jump. And this is the epic moment that we were all waiting for. Okay. Here's by 40 output, and we do the same thing once again. It's so great to see how things go. So if it wasn't for optimization, we should have done like add 40 times. Is not good. 120. And here we go, 0. If we had jump if 0, could have optimized for this. When we have a 0, we don't have to to do all of this. We can just output it directly. We don't have that command in this level. And we did it. It's not the best. There is an added thing, but I don't think we have anything to optimize. Like, it's probably there is. Um, like inbox, copy to 0, add 0, copy to 1, copy to 0, add 0, add 0, add 1, copy to 0. Well, anyway, we'll just skip through this. Boom, I'm speed. And this is how you multiply by 40, even if you're a nitty. Trick multiplier. Okay, so as you can see, CPUs are so stupid, but they're good at doing stuff. Like, they're so speedy, so fast, and they'll do anything you tell them to. Sometimes some numbers are bigger than other numbers. Well, we just finished the challenges. Now we're going to complete the other stages. Okay, now it will be much easier. We're going to get more commands and stuff like that. And sometimes they're the same. How can we know? I read about that here in this great book. Which number are you? For the inspirational 0. You can borrow it later. Okay. Get two things from the inbox. If they are equal, put one of them in the outbox. And discard no equal pairs. Repeat. So what we need to do. So it said that we need to get two numbers, and if those two numbers are equal, then we need to output one of them. And if they aren't equal, then we need to discard the two numbers altogether. We're going to go to the next pair of numbers. Okay? And we got a new thing. It's not really a new command, but it's just a comment. So here you can use this to put comments. Okay? To comment your code. That's basically it. So yeah, how we can do this. First, let's get the first number. Let's store it. Now let's get the second number. And here, where the magic should happen. Okay. So we got the second number. How we can know? Like right now, I'll pause for a second. I'll ask you about, do you have any solution in mind before I actually show you the actual solution? Just think about it for a sec. Because there's nothing better than getting up with the solution yourself. If you can, of course. If not, it's okay. Let me know if you got a solution. So this is the commands that we have. We have inbox, outbox, copy from, copy to, add, sub, jump, and jump if 0. Wait for 2 minutes. Sure. I'll wait for 2 minutes. Okay, I'll give you some time to think about it. How we can know that two numbers are equal? Just by using those commands. Oh yeah, here we go, Gojo. You figured that out. If I sub them, they become 0. Then I will have, yep. So if they're 0, then we know that they're equal. Like, we need to get those two numbers, sub them together, If the result is equal to 0, then we know that those two numbers are equal. Okay. So then we can we can outbox one of them. So congrats, Gojo, you figured it out. So yeah. All right, let's do it. So inbox copy 20 inbox. Okay. Now we're going to sub the other number. Okay. All right. Now we're going to see if the result is 0. We're going to see the result if it's 0. So Gojo figured out. I'm glad that you did, because I know that I'm a good teacher at least. All right. Actually, it's not about me teaching, but really it's just about you trying your best to think about a solution using some simple commands. Okay. Now we got the first number. We copied it to here. We stored it. We get the second number, and we sub it. Like we subtract the second number. And if it's 0, then we know that it's actually an equal number. So what we should do is copy from. We need to get the one of them, okay? Because right now, remember, as we did the subtraction, we're going to hold 0, not the number that we need, but we need to outbox the number, okay? So we're going to copy from 0 to get the number, and then we're going to outbox it. But what happens if it's not 0? Then we need to discard that pair. So how we're going to do that is just using a jump. And the same thing goes here. Or let me try something. I'm not sure if it will work. But I'm thinking about something. Let me see. So jump if 0. What if we did... Actually, I don't know really. Let's just use it the normal way. So if it's not 0, we're going to jump to the start of the program. If it's 0, then we're going to continue. Copy from 0. So we're going to get the number, and we're going to outbox it. And then we're going to repeat this whole thing for every pair. 6, we put it there, we store it, and we get the 1. 1 minus 6 is not 0, so we discard that. And 8. 8 minus 8 is 0. So we're going to grab this number because we're going to sort. 5, 5. 0, they are not equal, so it won't equal to 0. And minus 4 and minus 4, it will. Minus 4 minus 4 is 0. And grab that minus 4 and 8. And here we go. And here we go. We did the challenges, kinda. So let's go back and let's go step by step. Okay, so this is our little program. And let's see. So first, we get the first number. We got it. Now we need to store that number. We stored it in the RAM, okay? Now we're going to get the second number. Now we got the second number. I'm gonna get the second number, and I'm gonna use a subtract. Okay, I'm gonna subtract it from the first number. Here we go, minus 5. So we got minus 5. And let's see if it's 0 or not. If it's 0, that means the two numbers are equal. So we're going to jump to here, okay? But like here, it's not equal to 0. So what's going to happen is that we're going to jump back to the start of the program. As you can see, it's not 0. It comes here and it jumps back to the start of the program. And then we grab another pair, 8. The same thing goes on. We store that first number. We get the second number. We subtract the second number and the first number. We get 0, which means they're equal. So we don't want to output the 0 or the result of the subtraction, but they said put one of them in the outbox. So what I'm going to do, I already stored the number, which is 8, so I can grab that number using the copy from command. And as you can see, it jumped at 0, so it's 0, so we're going to jump there. So it's not going back to the start of the program, and we're going to copy from 0. So we're going to copy that first number, 8. We're going to outbox it. And we're going to jump again back to the start of the program, and it goes like that. Yep, the friends, pretty nice. If you understood all the levels of this, like if you understood all the levels of this game, you're pretty much, congratulations, you have a really good start. Like if you want to learn computer programming or computer science in general, this is a really good start. It really teach you a lot of the essentials about how computers work and how programming works in general. So maximization room. This is really how computers work, but again, you're just not using numbers like this or beautiful graphics like this, but you're just using binary assembly and stuff. So yeah, there's been a change of plan. And what I mean by binary is just 0 and 1. Computers only use 0 and 1. But this game makes it much easier to understand using normal numbers. There's been a change of plans. The accounting department has determined that treating all numbers equally is no longer profitable. Management wants the big numbers only. Okay, now let's see the task that we have. Grab two things from the inbox. So we're going to grab each pair and put only the bigger of the two. We need to put the bigger of the two, okay? In the outbox. If they are equal, just pick either one. If they are equal, then we can just like grab any one of those. Repeat, because they're equal anyways, so it doesn't matter which one you get. You got a new command, jumps only if the thing you're holding is negative, less than 0. Otherwise, continues to the next one. So we got a new command called jump if negative. Now, can you figure this out? I'll give you some time to try to figure out how we can resolve this challenge. You got a new command, jump if 0, and you have all the other commands that you used before. So how can we do it? I'll give you like maximum 5 minutes to figure it out, and then I'll show you the solution, or even 2 minutes. I'm not sure, but yeah, just try to think about it for now. How you can do a challenge. So basically, the challenge is how I can know if two numbers are bigger than other. Like I have two numbers and I need to know which one is bigger. So the last stage we figured out how we can know if two numbers are equal. So if any one of you is thinking about the solution, let me know. All right, so it's hard. Yeah, yep, it's a little hard, but you can figure it out. Just give yourself a chance, think about it a little, and we can start. So basically, you have those commands, and you need to figure out which number is bigger. And you have a new command called jump if negative. Remember the solution that we got for the first stage, for the recent one, and you can figure out. Okay, I'll give you some time, and then I'll tell you the solution. So that's right. What we can do is sub them together. If one of them is bigger than the other, then it might be negative or positive, not zero. If it's equal, it's zero. If it's positive, it might be something, and negative, something else. So let's see how we can do it. Let's grab the first number. Okay. And then, let's see. We need to grab the second number. Actually, we need to sort the first number first. Okay. We need to get the second number. All right. So we got the second number. Now what we should is sub it from the first number. Just like that. Actually, since it might not be equal and one of them might be positive and the other is negative, what we need to say is to sort this both. Okay, so let's copy to one. Now we got the two numbers stored. Now I can sub from the first number, sub 0, because I got the second number. Yep, store both, because it might be one of them might be bigger than the other. So I don't know yet which one is bigger, which one to store. So I'm going to store the two. All right. So copy to 1, sub 0. Now jump if negative. So I'll get a result. If it's negative, then we're going to do something. But let's see what we get. So 6 and 5. Let's see what we get. All right. We got a negative number. So when we get a negative number, it means that the 0, that the first number is the result, is the bigger one. So if it's negative, then we're going to copy from the first number, and we're going to Outbox. Okay? If it's positive, then we're going to copy from 1, so the second number, and we're going to jump. Actually, wait, no, Outbox, yep. But we can just Outbox, sure. And we can jump and repeat this whole thing. So as you can see, this is pretty simple. 8, 3, store both. 3 minus 8 minus 5, so we grab the first number. Minus 6, minus 7. Alright, minus 1, minus 6, go. 6 and 6, which means they are equal. So we're just going to do any one of them, it doesn't matter, because they're equal anyways. And management expected 0, but you outboxed 6. What happened? Wait. I didn't see what happened there. 6. Got it there. We got 6. Boom. Now, why it's subbed again? Oh, yeah. Oh, yeah. My bad. Need to jump again. So what I can do, instead of doing this, I can just jump here. I think. So, let's see how it goes. Six minus 6 is 0. So it will take any one of them. Doesn't matter. And here we go. Maybe we can actually optimize this more. Let me see. So the thing is, when it's zero, which one it picks? Like, wait, I need a zero. Basically 7 and 7, okay. So I need to know which one it picks. So when it's zero, yeah, I can pick anyone. No, that's not the case. Alright, not sure. So yeah. Now we can just get it off. We're legends. Okay, we made it. Continue. Alright, and employee moral insertion. Year 15. Basically, if you know how to program, you can optimize a lot of stuff using automation. For example, if you're good at networking, you can somehow optimize your data usage. I don't know. So yeah. Or you can make robots or machines that will go on the world, destroy it. Absolute positivity. And exclusive lounge. So the other stuff is a little hard. So I think I'm going to stop the gameplay here. I mean, we can do it, but it will just goes crazy. So yeah, we did 15, I think. Yep. Basically 15 stages. That was pretty awesome. And Gojo, you really like answered a lot of challenges, like all the challenges basically, which was awesome. And you guys probably learned a lot through this. And if we actually like complete all of this stuff, you basically know how everything works. But yeah, until now, you learned a lot of stuff. Not just math, but even how to deal with problems, how to deal with errors, how to deal with limitation. Uh, yeah, deep friend. If you want me to repeat some stage that you didn't see, deep friend, that I can do it for you. Let me know. So you guys who followed with me until now, you really learned a lot of stuff. How computers work. Uh, it's good that it tell you you're doing wrong. Oh, it's okay. Yeah, it's pretty good. Like that's all the programming language that will tell you like you're doing it wrong. Basically, in Lua, for example, Roblox, you have the output, which will tell you if something goes wrong with your code. So yeah, you also learned how to deal with problems, like how to make the problem, like to partition it into multiple parts, and then every little part you can handle it by itself. For example, in the tetra quantiplier thing level. Oh, did we do just quantiplier? Oh yeah, we did this one, but it didn't do that. Yeah. So for example, for the tetra quantiplier, we have like times 40, but we only have add command and storing commands. Okay. So what we did is, first of all, we used the solution of the octuplier suit, which means we used reusability. Okay, so we reused a solution that we did before. We used in this level, which is how to do it times 8. And we used that solution to get the number times 8. Then we added that times 8 solution with the times 2 solution. So we got times 10. And we used that times 10 in conjunction with the solution that we got in the tripler room and multiplier suit. We use that to get times 10 times 4. So we made it. And you can basically optimize any, any multiplication using add commands and storing and loading commands. Just using these two solutions. There's of course always more optimizations to do. But yeah, for example, the solution that you can do, that you can add if we had the command for is, for example, let's say you have a 0. So you can check if the number you have is a 0. If it's a 0, then you're just going to outbox directly 0. Because you already know that 0 times 40 will always be 0. Or 0 times anything will always be 0. So instead of doing a lot of steps to calculate that, you can just directly, if it's 0, directly, don't do any of that steps, just directly give it a 0. That's called optimization. Is that instead of using 40 add commands, we use just few commands, few add commands to do our job. And we use the results of the other one. Wait, can I try tetra multiplier? Here we go. I can clear everything for you, and you can actually tell me if you want to do anything. Right, so let's do the things that are so obvious, and I'll leave for you the other things. So inbox, we're going to store the first number. Yep. Okay. And then we're going to get the second number. And now you can do whatever you want after this. Yep, copy to 0. Want to use add? Maybe? Oh, no. Yep, that's right. Copy to 0 and add it. Yep. Add to 0, right? Okay. Again, add to 0. So now you got the number times 2. Actually, times 3, really. Yeah, times 3. You don't want this command? Okay. Now you got it just times 2. Place a copy to. Alright. So copy to, and where? To here, right? I think probably, yeah. Copy to 0. And add. And copy to. And add. So let me help you here and see what's happening until now, what you did until now. Let's get a 1. Trying to get a 1. Damn. Just not giving me a 1. Oh yeah. Come on. Yep, here we go. So here's what you did until now. So let's go. Copy to there. You added it, so times 2. And you put it, so times 4. Put it again, so times 8. Okay? See what you right now until now you multiplied it to 8. So what you said is now copy to 1 and copy to 0. But let me help you here. When you multiply by 2, you need that result. So you need to store the multiplication by 2 result. So how? Well, copy to 0 and copy to 1. Wait. Inbox, copy to 0, add, copy to 1. So you store the multiplication by 2. No? Okay. Let me remove this and let me know what you want to do now. Okay. So I copy to 1. Okay. Copy to 1 and copy to 0. All right. Add 0. All right. Copy to 0. There we go. Add 0. Oh, I think I know what you're doing, but yeah, whatever. Add 0. Add 1. I think I know what you're doing. But let me see. Let's see. 1. Okay. All right. So you're multiplying by 8, I think, and you're going to store the 8, and then you're going to go to, I think, 32, and then add the 8. God, nice. That was awesome. You're pretty good, though. That's pretty good. Pretty smart. Damn. Nice. Congratulations. Now the students will become a teacher. That's pretty cool. That's pretty good. And I think this way is more optimized, probably. Yeah, probably this one. Because you're using the other solution, which is you can only use like 4, you can only multiply by 4, 8, 16, 32, and then you grab the 32 plus the 8, and then you got 40. That's cool. So you grab the maximum number that you can reach before reaching 40, which is 32, and then you look for other numbers like 8, for example, then you got that number too. That's great. And yeah, it didn't solve this one, but it's pretty good. I mean, this challenges can be, as you can see, this challenge can be very difficult. In many cases, not possible to optimize both simultaneously with one solution. But that was very good. Very, very good. So yeah, I think we're going to stop a little here, maybe. What do you think? Gonna get a little break at least, and you can ask me any questions if you want right now, because the other levels will be a little hard. Let me know if you have any questions regarding anything, especially computer science. Not really. I did work on drop blocks. All right then. So what do you think about, let me show you maybe C and C++. What do you think? Yeah, it was so fun, really. I might actually go into apps like this stages. I can complete them, I guess. But they're so difficult. And I probably can't even explain them for now because I'm a little tired. So I learned C++ in 12. Yeah, that's pretty good. Do you know the SDL library? I can show you something very crazy. Are you down for that? All right. I think let's change up a little bit and let's do some C and C++. My question was too long. Which question? Okay, so I don't need this. By the way, 8 gigabytes. Let me tell you something. Let me tell you something. So, in human resources machine, we were dealing with numbers like this, okay? But in computers, you can only use these numbers, okay? Just 1 and 0. Do you have any idea about this? So what do you think, guys? Yes, all binary. This is called binary. And why it's called binary? Binary. Okay? I mean, it's like this, but you can say binary. I'm just like to highlight this by, which means two, two. And there's also the numbers that we use are called, let me remember, um, binary. I don't actually remember them. Wait, by. Let me see something because I don't quite remember what it's called exactly. Hmm. Let me get a new window because I don't remember something. By wiki by number. Okay, prefix denoting 10. Decimal. All right, decimal, decimal. So our numbers are decimal. Okay, so basically there is this like this. So let's clean that up. Yes, it has a base of 2 and decimal is has a 10. All right, let's clean this up. So binary, it does have a base of 10, base 10 numbers. Oh, base 2 numbers, goddamn. Because it's by, which means 2. Okay, and then decimal, which is base of 10 numbers, and deci is means 10. Okay, all right. So this is what we need to know. Computers use binary, which is a base of 10 to base of 2 numbers, which is only 0 and 1, 0 to 1, which is 0 and 1, and then base 10 numbers, which is from 0 to 9. Okay, All right. Now let's think about it. And let me read your comments, by the way. True and false binary. Yep. So a 0 is false and 1 is true. And how we can say it again? On, or actually off. Let's think about something else. Um, no electricity, no voltage. Okay. But here we can say true, on, electricity flowing, and there is voltage. Yep. All right. So this is basically one. One is true, on, electricity flowing, voltage is greater than 0, and 0 is false, off, no electricity, no voltage. And as you can see, now the question is that we need to answer here. Why computers use binary instead of decimal, which is our base 10 numbers, which is from 0 to 9, right? So the numbers that we use daily. Why computers use binary instead of decimal numbers? So can someone uh, answer this question through what I've said before, especially this part right here? I kind of made it clear here, but let me know if you can answer this question. Why computers use binary instead of decimal numbers? And Difran said binary has 2 as the base instead of 10, so only 2 numbers, 1 and 0. Yep, that's correct. So Gojo, I think, doesn't know how to answer this question, and I can assume that Difran, not sure, but I think he doesn't know how to answer this question too. But here, let me tell you. So, what are like basically the most essential components that a computer is composed of? It's just wires, yes, because you can do any mathematics and also do Boolean with only 0 and 1. Not sure. I mean, you do have, like, it's correct, but it's just not the base problem. Okay. So let me tell you why. Okay. Let me tell you why. But your answer, Dfram, was really good too. It's that also right. But here is the best answer. Why computers use binary instead of decimal numbers? Because they use wires. Like they can only read wires, okay? Voltages, okay? Now you're going to say to me something else, which is that wires can have multiple voltages, right? It can have 0.1 voltage, 0 voltage, like 0 point volt, 0.1 volt, 0.2 volt, 0.5 volt, 0.5. Like it can have like this numbers. But let me tell you something. If we do it that way, like most computers use, like, you can say from 0 volt to 5 volt. I mean the basic components like the CPU, information data, and stuff. Uh, Usually that's the case, okay? But the thing is, if we use 0, 1, 2, 3, 4, 5 volts, is that the computer will be less stable. Because let's say anything, for example, let's say you have a magnet, okay? Somehow that magnet can affect the voltage, okay? And if it affects the voltage, instead of 0, or instead of, let's say, of 5, you can get, for example, 4.9, okay? Let's say, just for as an example, okay? Which is not stable. And that's why engineers actually use the computers to do this. If the voltage is between 0 and 2.5, then it will read 0, okay? God. Okay? 0, okay? But if it's between 2.5 and 5, then it's a 1. All right? In that case, like even if it's, for example, let's say 0 point, like there's some noise or disruption in the signal, even if there is some little change, it will be, it will still be 0. Okay, which is pretty good. So the computers are very stable. So even if you got something that like disrupt your power, and somehow instead of sending 2.5 it's send, for example, let's say 2.4, then that won't change the number that it will read or write. Okay, so let me know if you understood what I mean here, and if there's any questions before I can go to the next one, because this is very important question that not a lot of people ask before even starting to understand what a binary is. Why computers use binary instead of decimal numbers? Because they can only read wires, messages. So that makes sense. I never thought about it like that. Yeah. So that's a pretty good question to ask before actually going through any other question. Okay. Now, the second question is, how can I represent big numbers? Or let's say, for example, the number big numbers, okay? For example, 3, okay? Using binary. If I only have two, like 0 and 1. So this is the next question that we should ask ourselves. And let me know if you have any idea about this. I'll give you a little bit of time to think about this, then I'll go to I'll answer you. So how can I represent big numbers, for example, 3, using binary if I only have 0 and 1? Yes. Yes, Gojo. Like 1, 1, 1. So basically, like our numbers. Let's think about how we do numbers. We only have 0 and 9, right? So let's talk about decimal numbers. We only have numbers from 0 to 9, right? But we still can use it like to say 1, like this is a 100. How I did this? Because we're using a system that is called, I'm not sure what it's called really, but I think dot notation or positional notation. Basically, that you can stack up numbers, and depending on its position, you can have a bigger number. All right? Oh, yeah. Now, that's for decimal numbers. But for binary numbers, I can say I can stack up a lot of numbers like this, and I have a new number, okay? All right, now we answered this question. Very awesome. Now, the next question that we should ask, how, or actually, let me ask you, what question we can ask right now first? Do you have any questions? And of course, this is not 3. Let's fix that. This is well, let's see. I think like this, yeah. 0, 1, 1, or just 1, 1, you can say. This is how to represent 3. But let me know if you have any more questions though. So the next question that we should ask ourselves is how to read a number that contains only 1 and 0. Yes, exactly. How 0, 1, 1 is 3. So let's use that formula. How 1, like 11, can represent 3. How 11 in binary, right, can represent 3 in decimal. How? So we're going to actually go with, okay. So the thing is, I'm going to go to Word because right there I can make some tables. And you know, you won't go out of this video without understanding how to read binary and how to write binary, okay? And you'll understand a lot of things. Like, you're so lucky. And I don't know if I'm going to like publish this video, like this live's replay. Not sure. But you're so lucky to be here. Because I'll teach you exactly how that stuff works. So, mise en page, no? Let me see how I can color the screen because white is so crazy. I don't like white on all my stuff, so how to do that? How I can change the page color to white? I think it's either one of these. Yes, full by. Yep. So I want a color. Let me see. All right, and I'll go with 30, 30, 30 because that's a pretty good color. All right, good. And I'll use a color white. All right, good stuff. Now, let me make a table. Okay, insertion, and I'll make a table. I'll make a table of 4. Okay, good. And since I can't really see the viewer count really good, I'm just gonna pick that up and put it here for the moment. Okay. All right, that's magic. I'm not sure how to make this white. Uh, dude, I'm just learning this. I don't know. I don't know. But I'm going to use one of these. Oh god. How to do that? This is pretty weird. Okay, let me try. Okay, that much better. Here we go. Now, here we go. So, do you remember when we just started school and we just started, but this is the table that we was doing. Do any of you remember this table? So let's say you have a number of 1,456, and then you can just like grab that number and put it here, 1,456. So here you have 1, so 1 times 6 plus 10 times 5 plus 100 times 4 plus 1,000 times 1. Do you remember this table? Or have you ever like even seen it in school? You probably did. Well, never did this. But I guess you can relate and you can kind of understand it, right? Gojo? I think you kind of got what I mean here, right? So we can represent the same thing using this. 1 times 6, right? Plus 10 times 5 plus 100 times 4 plus 1,000 times 1, right? And if you put this into a calculator, it will give you this. So we have a calculator, which is Google, just in case. 1,456. So this is basically it. We get this number, we multiply it by 1. We get this number plus, we get this number multiplied by 10, plus this number multiplied by 100, plus this number multiplied by this number. Now, Can I ask you a question? What do you see here? Now, we're working with a decimal number system, which contains 10 numbers. Okay? So, do you see some pattern here? 1, 10, 100, 1000, right? So, I can grab this one and I can say 10 to the power of 0. Yep, multiples of 10, because decimal numbers are a base of 10. So I can say here, instead of 1, I can say 10 to the power of 0. How I can do that? Well, let me see. Equation. Yes, 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 yes. I'm not sure how to do it. I think symbols, no? Dude, how to do it? Um, Let me see. For example, answer. Here we go. Here we go. I think I got you now. So here I should put, I think, wait, equation, yep. And then notation, yeah. Here we go. Here we go. So here I can put 10 to the power of 0. Okay, so instead of 1, I can say 10 to the power of 0. And every number to the power of 0, it's 1. Okay? And 10, instead of 10, I can say 10 to the power of 1. And because 10 is just 10. And 100, I can say 10 to the power of 2. Because 10 times 10, so 2 times. Okay? And 1000, instead of 1000, 10 to the power of 3. Because I get 10 and I multiply it by like 3 times by itself. You understand what I'm doing here? 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, 10 to the power of 3. We add another colon, or I'm not sure what it's called. We can add 10 to the power of 4, 10 to the power of 5, 10 to the power of 6. Alright, cool. Now, can we apply the same strategy to binary? Can we do that? Let's try. I'll just copy this table right here, and I'll let you guess what we can do here, how we can change this. I'll let you guess. So tell me what we should change about this table to get it from the multiples of 10 or the base of 10 to the base of 2. What we can do. So what do you think? So we have this second table, and we want to use it for binary instead of decimal values. How we can do that? What we should change about this table? And 1 second, I'll be back. All right, wait. All right, back. So different set powers of 2. 2 to the power of 0 is 2 to the power of 4. So I guess you understood the point, okay? So instead of 10, I'll use 0, 2, right? 2, here 2, here 2, and here 2. Yep. Now I got 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. But there is one thing, is that I can't use numbers like 6, 5, 4, 1 because it's only base of 2. So I can only use 0 and 1s. So let's say this is 1, 1, 0, 0. And you can see what's going on here. We got 11, 0, 0. So how we can calculate this number and convert it to decimal, which is 1, 1, 0, 0, which is just binary of 11. So what is binary of 11? in decimal. What is it? How we can calculate that? Well, 1, so 2 times 2 to the power of 0. How much that is? 1, right? And 2 to the power of 1 is 2. And 2 to the power of 2 is 4. And 2 to the power of 3 is 8, right? Cool. Now, as you can see, we did it. All right. Now, how we can do that? So 1 times 1 plus 2 times 1 plus 4 times 0 plus 8 times 0. So let's actually see how we can calculate this. Uh, so 1 times 1 is 1 plus 2 times 1 is 2 plus 4 times 0 is 0 plus 8 times 0 is 0, correct? And let me get that viewer count to the other side because it's probably messing up. So here we go. So I think you got what I mean here. So 1 plus 2 is 3 plus 0, 0, 0 is 0. So 3, right? Which means the binary number of 11 is equal to 3. Yep, it keeps going. When I want more stuff, more bigger numbers, I can go ahead and I can add more places, right? And I can just go on with multiples of 2, powers of 2. So 2 to the power of 4, 5, 6, 7, 8, 9, 10, and go on and it goes on. So you see how that's so cool, right? So the binary of 11 is equal to 3. Or I mean the binary number that is 11 is equal to 3. So yeah. Now, here is uh, a little challenge. Can you let me know what's the maximum number that I can do using just this table? Okay. So for example, here, what is the maximum number that I can use in decimal in this table with 4 places? I can say 9, which is the maximum number. 9, 9, 9. So the maximum number that I can represent using decimals in 4 places, it's 9,999. Now, can you let me know what's the maximum number I can represent in decimal in this table right here? Of course, in binary. Okay? Can you let me know in binary? So 1,111, correct? Okay. Now 1,100 1 like 11 and 1, all right, or whatever, 1111. All right, now yes, in binary. Now the next challenge is how I can, like, if I convert that into a number, what it will give me. Okay, try to think about that and let me know. 15. How you got 15? Okay, let's see. Let's see if it's 15 or not. I don't think it's 15 actually, but let's see. So 1 times 1, which means, so I can just like add up this number basically because they're all 1, 1, 1, 1, 1. So I can just add them up. I don't need to multiply. So 1 plus 2 plus 4 plus 8, okay? Which equals to 4 plus 1 is 5, and wait, 8 plus 2 is 10, right? 10 plus 5 is 15. Yep, that's right. 15. Now, let me tell you something. What do we mean by this? That we have 4 places. It means that we have 4 bits, okay? That's 4 bits. So in 4 bits, using 4 bits, we can store a number as large as 15, okay? From 0 to 15, all right? So you understand what I'm doing here? Oh God, my viewers are so smart. Okay, so yeah, I think you got you. Now, what we can do with bits. Now let me show you something very cool, okay? All right, now let me go back here. And how much gigabyte I do have in my RAM? It's 8 gigabytes, okay? Now let me show you something. 8 bits is equal to bytes, okay? So 8 bits is equal to byte. Now 4 bits is a half byte, all right? So 4 bits is equal to 0.5 bytes, all right? Now if I want 8 bits, let me make a table of 8 bits. I'm not sure if I can extend this. I probably can, but I need to know how. Let me see. I hope this is easy. How we can do it. Um, I think this is the case. Yes, dude. How I did it, I don't know. Now, let's do this. 8, 16. So we're going to go with powers of 2. So this is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and here 2 to the power of 4, 16, and the number 32. So you basically keep multiplying by 2. 32, 64, 128, and 250. I think 56. I think that this number might be familiar if you're developing, especially if you're using RGB numbers, you know? Ah, okay, that's crazy. This is crazy. Okay, let's go to Roblox. Let me show you something very cool. Let's go to Roblox. I'll show you something mind-blowing right now. Okay. So first of all, let me see how much numbers I can represent there. Let me see how much numbers. So to know how much, I can just say 1, 1, 1. So this is the maximum number that I can represent. 8 ones, okay? Now I can just add this stuff up. So let me get a calculator. So 1 plus 2 is 3. 3 plus 4 is 7. And 7 plus 8 is 15, right? So 15 plus 16 plus 32 plus 64 plus 128 plus 256. So we can represent a number as big as 511. Okay? So yeah, something like that, around that position. Now, the thing is, I'm only saying here the maximum number, okay? But what about variation? How much variation, how much number I can represent using this table? Not the maximum number, but how much variation. So how I can do that? Well, um, so we have here 8 bits, okay? So 2 to the power of 8, which is, wait a sec, am I getting this right? Not sure. Um, I'm not sure if that's the case. So 2 to the power of 8. Okay, 256. Is that right? Um, What about, not sure really. But we'll go back to that later on. Now, this is 8 bits. Cool. Now let's go to Roblox. Let me show you something. Base plate. Okay. Base plate. Point in place. Base plate. And home. Let's get a part. Okay. The properties. And let's get to the color. Okay. Now, do you see this red, green, and blue? Right? Let's see the maximum numbers here. Okay, I need to get this up there. And now see what's the maximum number here? Can you see it? Let me know what's the maximum number here. So what's the maximum number in this places right here? I'm not sure if you can see it. It's 255. And actually, let me show you a much better way of doing it. Let's go to the web, right? And let's look for an RGB color picker or color anyway. I think this can see. Yep, I know can see very well. So this is what I'm going to do here. So you have this RGB colors, right? Red, green, and blue. RGB. Okay. So you can see that the maximum number here is 255. Okay. And the minimum number is 0. All right. So 255, 0. Now, what that means? What I want to tell you by this. Can someone can someone figure out what I want to tell you by this? So 255, okay. And here 256. So there is a relationship between this and this. Where is it? Where is it? Here we go. By this. So the maximum number of each of these colors, RGB, is 255. Okay, so can you tell me, can you like figure out what's going on here? Kinda. It's starting, yeah, it does start from 0, and the maximum number is 255. So let me tell you, is that these numbers use a 250, like 8-bit. They're stored in 8-bit, which is 1 byte. So in your computer, those numbers are stored in 8 bits, using 8 bits. That's why they can only go from 0 to 255, where 0 is the minimum number, or black, and 255 is the maximum light, or basically white. Okay? So you understand what's going on here? I think that's pretty cool. So every number of these is represented using 1 byte. And for example, 255, actually, 128, so that should do the trick. Yeah, so you can just say 1. Actually, 1 is 111. All right, just like that. 7 bits, I think. You can say 8 bits, because if I actually added these numbers together, let me see, 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, 255. Okay, actually, yeah, that's right. So they're using 7 bits, but I'm sure they're using 8 bits, and I think that the second bit is used for something else, right? Because they can't actually use only 7 bits. They can use just 8, like 4 bits, and goes on like that. So yeah, so that's the thing that I want to say to you right there. So actually, they're using 7 bits, and the other one, the last bit, is probably used for something else. Not sure what they're used for. I never really seen about that, but yeah. And now let's think about it. So every number is, let's say 8 bits, which is a byte. Okay. So a byte plus a byte plus a byte. So every color can be stored using 3 bytes. Okay, 3 bytes, right? Cool. And every one of these number, for example, red is represents how much light, how much red light there is. Okay, the green is representing how much green light there is, and the blue light is representing how much blue light there is. Okay, and now what if I get blue and green together? We get this kind of color. And if we bring red too, so all of the colors are at the maximum, we get white. Okay, because if you mix red light and green light and blue light, it gives you white. But wait a sec. If you get a paper, if you get an ink, red ink and green ink and blue ink, so 20, what is why they have part 3? The little light bulb just went off. Yeah, exactly. That's how it works. Like, your screen is just a lot of pixels, but I'll come to that in a second. Okay. So as you can see, now only one note here, as I said, only one note is that mixing light is different from mixing ink. Like if you get a blue pen, red pen, and green pen, you won't get a white color. Instead, you will get a black color. Okay. So I just want, because if you're working with paper ink, then you're going to use something called CMYS, like CMYK. Okay. CMYK. So this is the colors of. Okay, let me show you something. CMYK. Actually, RGB here. RGB. RGB images. And I'll show you light here. And this one really looks good. Or actually, it's so small. So let's go with this one. Or this one. Yes. Let's get this image. Where is it? Where is it? Where is it? Open image in new tab. Okay. And CMYK. Or actually, this is a pretty good one. This is the pretty good one. This image is perfect. All right. Here you go. So this is light, which is for RGB. And this is ink or paper, which is CMYK. Okay. So C is cyan, and yellow is yellow. And here, I'm not sure what this called, but yeah. So if you mix these 3 colors, it gives you black in paper. Okay. But in RGB, or red, green, blue, in light, using light, you can get a white color mixing all the essential colors. Okay. So yeah, if you mix red and green full intensity, you get a yellow. If you mix this red and blue, I'm not sure what's this called. I think pink, kinda. And then if you mix blue and green, you get this color, and so on and so forth. And if you mix different values, then you get different colors. Okay. And there's also the hue colors. Hue colors, like hue color picker. Let me show you another kind of color pickers which we used, which is HSL. Yep, HSL color picker. In Roblox, it's called HSV. Okay, so this is the hue. I think magenta. Yep, I think magenta. Hypercloud, and welcome to the stream, Hypercloud. You have the hue, which is just the colors of the rainbow. So there's 7 colors, 7 main rainbow colors. And then here you have the saturation, just how popping the color is. The more saturation, the more the color is really like bright. The less saturation, the color is very sad, kinda. And the value is just how much light there is. At maximum, it's a white, and at minimum is a black. So there's multiple ways to represent the colors, but generally, in your system, it's using a RGB color to represent colors. Now let's ask something. Let me ask you something. How screens work? How screens work, all right? Let me see how screens work. I'll show you something cool. And this time I'll use Excel because it's much better than this because it have a lot of tables. Okay, good. Now I kind of want this to be squarey. I'm not sure how to do that. There's probably a button to do that actually. Let me try to see if I can do that. Maybe this one, hopefully. Yeah, it might be. Let me see. Alignment, no. Police, no. Board, no. No. Wait. Yeah, here we go. Let's go with, I think, 32 maybe. No, that's too big. Let's go with 1. That's too small. Okay, let's go with, wait. Lava, yes. I think 8 should be good. Yes, 8 is good enough to show you something. Okay. All right, here we go. 8. Oh, it's not the same for some reason. Oh yeah, sure, D-Frame, we'll miss you a lot. And good luck. Thank you for watching. All right, so I think here 16 could be better. Wait, not sure how to do this. God. So whatever. I'll show you what I mean here. Okay. And let's say this is my screen, okay? So let's say this is my screen. It's black, which means, and these cells are pixels, okay? And every pixel can contain a RGB value, all right? And my PC or my GPU, let's say, can change that colors using RGB values. And with that, it can draw all sorts of things, okay? And this is how your computer works, how a computer monitor works. So I have all of these pixels, right? In this case, I only have, I guess, 17 times something. Wait, I've seen it somewhere. Yeah, I have 25 pixels times 17 pixels. But for example, my monitor here, it have 1920 times 1080. So the monitor that you see here, the screen that you see here, have this kind of pixels. It have 1920 in the width and 1080 pixels in the height. Okay, and in total there is 200, like actually 2 millions and 73,600 pixels. That's a lot of pixels. And that's why I don't see squares in my screen, because the pixels are so small and every pixel is colored differently, depends. So to draw me all of this stuff that I'm seeing here, okay? Because if you come to zoom in on this, you'll find it just kind of like pixels, squares, okay? Not sure if I have GIMP, because if so, I can show you this more clearly, but I can't. But let's go with pixel art. I'll show you something more uh, better. Show you how we can draw stuff using only squares. Okay, so see this. It's only squares, and I can draw such thing right here. This is art, pixel art, okay? So every pixel have its own RGB value. And so I know that every pixel contains R, G, and B, and every one of them contains 8 bytes, or byte, 1 byte, okay? Which is 8 bits. So every pixel contains 3 bytes. And let's say I have an image which contains 32 times 32 pixels. Okay? So, and I want to know how much size that will be. So 32 times 32, which is how much pixels I have in the width and the height. And I know that every pixel contains 3 bytes. And so it contains 3072 bytes. And if I want to go into bits, I can grab that number and do times 8. And now I get how much bit I need to store a 32 times 32 image. That's too much. But there is something called compression that we use to actually make this number much less, okay? So let's see how we can compress something. For example, instead of storing every color of every pixel, what you can do is let's go back to Excel, okay? So the normal way of storing stuff, storing images, let's say, is that we can store every pixel color, okay? But what we can do is that we can go ahead and let's see how much pixels we have here. We have 17, right? So I have 17 colors. So I can say I can store in my file that I have 17 RGB. So basically 17, let me see. Let me do it here. Let me try, for example, to do it here. So 17 times RGB and then 0 because we have a black color, right? Okay, but we don't have just 17, but also another 17 and another one. So plus 17. So if we got a calculator here, we got a calculator. So 17 times 2 and plus 1, which is 35. So 35 black colors. And so as you can see, that's how we can store. Instead of using all of those numbers, you can use only 2 numbers to store them, which is pretty awesome actually. So yeah, that was basically it. Alright, so I'll be back in a sec. So I'm back, and as you can see, we can do a lot. And where is it? Where is it? Where is it? Where is it? Don't know where I put it. Sublime text. Yeah, it's been 2 hours. It's actually 3 hours. But yeah, I think we're going to end the video here. Let's end the stream here. But as you can see, you learned a lot of things. You learned binary, problem solving. So yeah, not counting your previous. Yep, not counting my previous. I think I'll leave this reply. So if you want, I'll leave a replay video in my channel. So if you want to share with anyone this video, it's pretty useful. So yeah, goodbye. Do you have any questions before ending the stream? All right, goodbye.